Okay, hi guys. So in this lecture, we'll be seeing some of the examples of HEME or Hoffman exhaustive methylation and elimination. Some examples and practice on that. Okay, so let's get started. So we have something like NH3 and CH3I, and that we have in excess. So what would be the product form? Product form would be simply N plus CH3 and I minus. Okay. Second example, let us say we have this thing, and we have two hydrogen atoms attached here, and um, so for getting this compound converted into something like this 2 moles of alkene, how many CH3I would be required? Okay, so it's a homework problem for you. You need to get the answer. Okay, third is we have something like this and H here, and we are passing it with HEME. We get compound A, and again we pass it with HEME. We get compound B. So what are A and B? So if we pass so if we pass this with first CS3I in excess, second we have moist Ag2O, and third we are heating this. So what we'll be getting is we'll be getting something like, oh, I missed this. So we'll be getting something like this, and this would be A compound, and again if we pass it through HEMA, again all these reagents will be getting something like this. This will be our B compound. Okay, so I'll just tell you the answer. I forgot to tell you the answer for this homework problem. So the mole of CH3 required would be 4 in this case. Okay, how? Obviously you know that you need 2 CH3I for this nitrogen and 2 CH3I for this nitrogen, and the remaining will be taken care by moist Ag2O. Okay, so 4 would be the answer. Okay, we have something like this, and we pass it in HEME. We will get something like A product, and again on passing with HEME we will get something like B. So what are A and B here? Okay, so let's say I'm passing this with this one and CH3I. So nitrogen will attack on CH3I to form a product something like, oh, this is not H, sorry, product something like N plus and CH3. We have H also, and this I minus will actually attack on H to remove this, and we'll get something like N here, and plus HI would be released, and this lone pair will again attack on CH3I, and we would get something like, again positive charge and 2 CH3 groups. Again on passing it with the moist Ag 2, we will get something like AgI will be formed, and Ag to OH minus would be there, which would actually be attacking on. Now which would be compound A in this case? Would it be attacking on this um, this acidic alpha hydrogen, or this one? So which of the two uh, alpha hydrogens would this OH minus would be attacking to? Okay, so when we actually saw the formation of Hoffman and Sedzeff rule, we actually saw that NMe3 was very weak leaving group. Hence, carbonyl was formed in the intermediate. Hence, the stability of carbonyl will determine the on as in which alpha hydrogen would be removed by OH minus. And this is not NMe3, but this is NMe3 like compound. This is still a weak leaving group because it's a good base. Hence, OH minus will be attacking on this alpha hydrogen. Hence, A compound would be this. Okay, had it been you marked A compound as this, your answer would be wrong. Okay, so that's why I showed the mechanism over here. Otherwise I could have directly wrote directly this compound here, but there was a important thing to show here. Okay, now obviously when you pass this in IIT-JEE again, you will get anyhow the same compound, which will be this would be compound B. Okay, now let's look at another example. We have here this one and this one, and when you pass it with HEME, what will be getting is compound A. Again, when you pass it with HEME, you get compound B. Okay, so just this thing has to be answered, that which again this is not H, I am sorry, which alpha hydrogen would be removed by OH minus. Would it be this one or would it be this one? So again, as you can see, the partial negative charge is more stable either on this or on this. Obviously on this it is more stable, hence A compound would be something like this. Is again a bond, there is a carbon here. Okay, this is the A compound. And what is the B compound? Again, when you pass it with HEME, we will get something like bond between this. So this is the compound which we will be getting. 3 4. Oh no, there is one atom I missed in between. That has to be 1 2 3 4 5. Yes. Let's see another example. Here we have something like, we pass it with HEME. Okay, so what will the alkene formed in this case? So the alkene formed will be, we can have, after we get something like this CH3 here, next OH minus will be attacking on which carbon? This one or this one? If you look at it closely, this will be getting partial negative charge, this will be getting partial negative charge. So we have to determine which partially negative charge in the intermediate is more stable. Okay, and this is obviously more stable. Why? Less number of plus I groups attached to it. Hence we'll get something like this, and we'll get something like this as well. Okay, now you again pass OH minus to it. Oh, this would not be a positive charge anymore. Again reacted with HEME, what will be getting? We'll be getting surely this time double bond between this and this carbon. Okay, so these are the two products. This would be the A product, this would be the B product. Okay, now let us see another example wherein we have something like this. Pass it with HEME, what will we be getting? Before the OH minus attacks on it, we will be getting something like N plus and 2Me. Okay. Oh, we won't be getting any plus charge here. So next what we'll be getting? After OH minus, we'll attack on this carbon and we'll be getting a cyclohexene. Okay, let's look at another example. So in this case we have something like this A compound which on reaction with with 2 moles of hydrogen gas, presence of Ni gives me B compound, and in this B compound on reaction with HEME gives me this. Okay, so what are A and B compounds? So obviously B compound has to be something like this. That we get something like N here and obviously H here. Okay, then only we'll get something like on HEME we'll be getting double bonds here and here. 1 2 3 4 5. It is 5 carbon. So 1 2 3 4 5. Okay, 1 2 3 4. It's 4 only. So what we can do is okay, this is the compound which has to be formed. Okay, so for this would be the product on which an HEME will give this compound. Hence 2 moles of hydrogen would be something like this would be our product, compound A. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing more of such examples. Till then, good luck and goodbye.